Yeah, I got a haircut. So here we go. This is your practice test. It's the one that starts out with a problem one with 6 little multiple choices in it. So if you're looking at problem one, it has little A through F. You're looking at the right problem one. So here we go. You have to do this rule, log to the base b of b to the 3. If you saw the previous video, we beat it into the ground. Everybody should know that's a 3. Next up, e to the natural log of x. They're on the same button on your calculator, so they're inverse functions. So these two guys undo each other. It just comes out to be just the x. So if you want to think about it, it's the power I would put on e to get x is this much. The power that's what a logarithm is, it's a power. The power I would put on e to get x is here, and I put it as a power on e. So I get x, and that's how that works. Or just think about it, the two inverse functions undo each other. All right, next up. This one says it's the log of 19 plus the log of 3 over 19. Well, the log of something plus the log of something is the same as the log of the product. So I have log of 19 times 3 over 19. The 19's cancel. This is the log of 3. Now, if you do that on your calculator, you can do log of 3 if you want to. And it's going to come out to be, let's see if I can get this to show for you, 0.477. I like log of 3. It's a full credit answer. So is the 0.477. Log of 3, you can have as many decimal places of accuracy as you want. Letter D, it's a rule where you have something to a power times the same thing to a power. You add the powers. That power should be m plus 5. Next up, here's something to a power raised to a power. So you multiply the powers. That's e to the 6th. I want to see the e to the 6th if it's a rule question. If it's an evaluation question, you can do e to the 6th if you want to. It's more writing. It comes out to be 403 if you do it on your calculator. Let me see if I can get this. God, I hate this so much. There you go. 403.43. Next up, I have a natural log of e to the 3x. So these two are inverse functions. They undo each other, and I get just 3x. So you should be able to do all those kind of things. While I'm erasing, you can check out my glove that Mary Beth made for me. She knitted up this fingerless glove, and I thought, well, there's the infinity gauntlet, but if you really want to survive the quarantine, what you want is an eternity gauntlet. So we picked out some religious medals and jammed them, sewed them on. So, yeah. So I prayed a rosary with it today. It felt really powerful. All right. Problem 2 was a little story problem. And the only graph that possibly matches is the one that starts here, goes through at 2, and it has the equation y equals 2 times 0.8 to the x. You have to have a base less than 1 to get this decay looking curve. But when when x is 0, that's x. This is just times. When x is 0, I get 2 times 1. So I have a point right there at 0, 2. Problem 3. You're going to set aside $10,000. $10,000 for 47 years at 4%. So that guy's going to look like this. And the only graph that looks good is the one that goes past 40. There's a graph there that goes past 40. And it's got the increasing. And it's cutting through here at 10,000. You have a 10,000 right there on the y-axis. Now the graph on the paper looks better than this one, but that's the one to choose because it looks like it goes up to 47. But the 47 isn't marked. Okay, number 4. On your practice test, it's 10 million ducks, and Thanos is he's the bad guy in the Avengers Endgame. He snaps his finger and half of all life dies. So Thanos is killing these ducks. Well, the first time he snaps his fingers, it goes from 10 million to 5 million. And then the next time, you could divide 5 million by 2 again, and you could divide 5 million by 2 again. But the thing is, how many times does he have to kill off half the ducks before he gets to less than 5 ducks. So I'd rather just do the math and get to the answer rather than keep dividing by 2 and then keep track of how many times I divided by 2. So the equation goes like this. You have 10 million ducks, and it's times 0.5. That's 1/2. Let's call it to the big T. T for time. How many times you're gonna cut the population in half? T for Thanos, because he's the bad guy killing these ducks. And you want this thing to be equal to or less than or equal to 5. We need a cutoff. You know, if we get 0.49, good, because we've just cut it down to less than 5 ducks. So how do you solve this thing? Well, you're going to divide by 10 million, and you'll have 0.5 to the big T equals 5 over 10 million. That's a very small number. And then you're going to take the natural log of both of these things. Let's see, we're getting kind of close to the bottom of the board, so I'll write over here. I'm going to have the natural log on my calculator. I'm going to have the natural log of 0.5 to the T, which is the same as having T to the natural log of 0.5. And do not lose that point on that 5. And then that's equal to this 5 over 10 million. All right, so I have T right on street level where I can access it. So on my calculator, I'm going to do 5 divided by 10 million, do that, and then divide by the natural log of 0.5. Now, when you, oh, sorry, you have to have this thing be a natural log in front. My fault. I'm taking natural log on both sides. There we go. Thanks for correcting me there, Greg. Good catch. And Yolska probably noticed too. I have this thing, and I'm going to take the natural log of both sides. So you go from this equation over here, take the natural log of both sides. You have to take the natural log of both. That's the only way to do it. So this comes out to be a negative number right here. But the natural log of 0.5 is a negative number as well. So if you do the final step, solving for T is going to be the natural log of 5 over 10 million and that's divided by the natural log of 0.5, and that T comes out to be, you do this on your calculator, you do the division correctly, it's going to come out to be 20.9 with some other stuff. So actually 21 is the right number of times, because 20.9 is going to give us exactly 5. We want less than 5 ducks. You know, so you got to have less than 5 ducks. So 21 times is going to cut the population in half. That'll be the first time after that 21st cutting the population in half. We'll actually have fewer than 5 ducks. Hope that one made sense. The book loves these little story problems, and I do too. I'm not afraid of them. I can do a little story problem. Next up is number 5. Oh, any questions so far? Are we okay? Zoe, are we all right? Good. All right, number 5. Number 5 was, let's see. I'm going to have, I have functions to get the inverses of. So 6 to the x has its inverse function. F inverse is log to the base 6 of x. The function is log of x. The inverse function is 10 to the x. Let me get this board looking better for you. The function was 3x plus 2 over 5. The inverse function is going to be 5x minus 2 over 3. I did opposite operations in opposite order. Or you could switch the letters x and y and solve. And the last one was, I think that's it. Oh, x plus 5. X plus 5. And the inverse is going to be x minus 5, of course. Can you see that okay? The inverse of x plus 5 is x minus 5. Number 6, problem 6. We have some rules to finish. b to the x to the y is going to be b to the xy. That's the rule. Log of a to the m is equal to m log of a. And the last one was log of a plus log of b. And that's log of ab. Hope we can read that okay. I'm going to erase number 5, make some space. All right. That was number 6. Number 7 was that I went back to that problem because it's always in the news about we did exponential growth. We did an exponential growth problem for the city of Wuhan, and I stopped after we found, I think it was like 175 million would be dead in 4 months. I forget the exact calculation, but we got this insane number because Wuhan only has 10 million people in it, 10.1 million or something. So you can't have 175 dead people. We only got 10 million to start with. So what was bad about it was we used an exponential, an unbounded exponential, let's just say an exponential function for long-term growth. See, what happens is we're using a function that it's growing slowly, but then it shoots up like a rocket, like all the exponential functions do. Well, it's eventually going to get bigger than the number of people that are in the city. So the model might work well for here, for small time chunks. But as time goes on, that model's no good. And we have other models. The mathematicians have other models. Number 8, and I think it's the last one, we have 17 equals 3 to the x. Well, everybody knows they got to take a natural log of each thing. So you take the natural log, or the regular log, I don't care. Oh, look, I wrote 71 instead of 17. So funny. Natural log of 17 equals natural log of 3 to the x, which is equal to x natural log of 3. So that means that x is equal to, and this one I hope you're just fine with, I have natural log of 17, which is just a number, divided by natural log of 3. X equals the natural log of 17 divided by the natural log of 3, which is a fine answer. But if you want an actual calculator problem, you do the natural log of 17, and it's divided by the natural log of 3. And the correct approximation is 2.58. Now let's look at this problem. 3 to the second is 9. 3 to the third is 27. So 2.58 is a fine answer because it's between 2 and 3. You know, you can try it on your calculator. Do 3 to the 2.58. You'll get very close to 17. All right. Check the next video. It's going to be similarly named as this one, except it's going to be number 2, to check your other practice tests. So I sent you 2 practice tests. You do them, and then you check these videos. See you later.